Welcome to the Noesis tutorial modifying and recompiling source characters. The purpose of this video is to give you the tools needed to enhance your modding experience. You'll be able to customize Half-Life 2 characters to suit your needs. We'll start by showing you how to extract models, so in future you will have the full Half-Life 2 library at your disposal. This includes everything from props to people. Our example will be a citizen, which is one of the most widely used models in the game. He will be fully functional by the time we are finished. Following our extraction, we will go through the process of decompiling so we can get the model and textures into a usable format. This is a pretty straightforward process that I will be guiding you through every step of the way. We will also cover decompiling the newly introduced Episode 2 models. Once we have our files ready, we will start working with the powerful 3D modeling software XSI. We'll import our textures and model into this program and have our first detailed look at the valve model. We will discover the problems associated with the decompilation and importing into XSI from another program. We will learn how to rectify these problems so that our model will be ready for the next stages of the process. Next, we'll learn how to rig the model and discuss the methods for weight mapping it. This will open the door for possible custom animations that could range from a simple sequence to the more complex animation gestures and postures. The final use of XSI will be to export our model, and for a more game-ready model, we will learn how to create level of detail models. This we will find will be important for game performance. All our hard work will be brought together as we look in depth at the Control Center for Accurate Compilation, the QC file. We will discuss in some detail how this file works and how it affects the end result. We will also learn how to add other Half-Life 2 animations to our citizen that will give us a myriad of options for future choreography. Finally, our textures and model will be compiled using the Episode 2 engine so that we can view them in PhasePoser and in the game. We will see the model deform and animate in the Half-Life 2 universe. Before we can start the tutorial, I want to discuss my desktop and the tools and the shortcuts. Basically, all of this from GCFscape to PhasePoser is the workflow that we're going to go through. You'll also notice that I have a folder called EP2 Source. This is our storage folder. This is where we're going to put our extracted model, our decompiled model, and textures, and everything like that. So if you want to create this folder, I'm going to show you where to put it. I'm going to go in, and I'm going to go up a directory, and here you'll see EP2 Source. It's located in C, Program Files, Steam, Steam Apps, Your Username, Source SDK Content. Now, the Source SDK Content isn't a folder I created. It's part of the Source SDK. I created the EP2 Source folder inside of it, and just as a centralized location for the model. So you might want to do the same. Again, the path is C, Program Files, Steam, Steam Apps, Your Username, Source SDK Content, and then just a folder called EP2 Source. And I'll be using this folder a lot, so I think it'd be advantageous to create it if you want to follow along and do it as I'm doing it. Now let's look at the tools. I'm going to start up here with GCFscape. GCFscape is used to extract the model and the textures, and this program was created by an individual. It's not part of the Source SDK. It's a self-installing program, and I'm going to go over where to find it in just a minute, but basically if you googled in GCFscape it would come up, but I'll give you a link to it in just a second. Like I said, it's a self-installing program, so it's very straightforward. It'll prompt you where you want to place it, and I've created a shortcut. Basically, it's the default C, Program Files, GCFscape. Once it's installed, it'll appear in your Start menu, so it's very easy to find. And it's just like any program you buy. It has a really nice installer, so it's easy. And then after that, we'll be using Steam a lot, and my Steam executable is located in C, Program File, Steam. Again, it's the default. That's where it went when I installed it, and so I just made a shortcut and I've put it on the desktop just to make things quicker to get to instead of fumbling around with all these folders. Next is VTF Edit. It's our texture decompiler, and it can be found on the same site as GCFscape. It's been created by the same person. It's called Noesis Tools. But again, if you just Googled in VTF Edit, you will find the program. And again, it's a self-installer. It's a really nice, easy program to install. And if I'll just show you, it's on the default. See, Program Files, VTF Edit. So you can just install the default and make a shortcut to it. Now let's look at Model Decompiler, Eric's Fix. The Model Decompiler is a little bit different from these other tools that have been created by individuals. This one comes in two flavors. There's the Model Decompiler, the original, created by Cannon Fodder, and then there's the Model Decompiler, Eric's Fix. It's still the program created by Cannon Fodder, but it's been modified by a person called Eric's 920. He modified some things which made the flexes work a little bit better. And this program, you're going to download it from the Noesis Interactive website. And it's going to come as a zip file. And inside of the zip file, you're going to find just an executable. It is not a self-installing program. But the thing that is really important to note about this program is that it must go in a very specific directory. Otherwise, it will not work. We won't be able to decompile models. So I'm going to show you where you want to put this. So if I go into my EP2 source folder, and I go up a directory, and I go up another directory, I'm going to go into Source SDK, bin, Episode 1, EP1 folder, bin, and here you'll see a lot of executables like Hammer and Face Poser for Episode 1. And if I scroll down, you'll see that I have the Model Decompiler Eric's Fix executable in this directory. All you have to do is open up your zip file and drag and drop the executable into this directory. But if you try to put it in your Episode 2 bin file, it will not work. It's looking for specific DLLs, and you'll just get an error. So it's very important. I want to stress again, it needs to go in your Episode 1 bin directory. Let's just go through that path again. It's C, Program Files, Steam, Steam Apps, your username, Source SDK, bin, EP1, bin. And you want to drag and drop the executable into this directory. So I just wanted to stress that because many people make the mistake of putting it in the wrong directory and then wonder why it doesn't work. So if you put it here, it will work just fine. Okay, next we're going to look at XSI. I'm using XSI Mod Tool. Basically, you get this from the Softimage website. Again, I've just created a shortcut. It's a self-installing program, very professional, obviously. And it'll be in your start menu. And depending on where you've put it, you just go and you create a shortcut and put it on your desktop. Of course, you don't have to do this, but this is how I've got it set up. And it's the workflow of the entire tutorial. So it'll make it easier if you put the shortcuts on your desktop. Next we have the Studio Model Compiler and the VTeX Texture Compiler. And also Face Poser. I have a shortcut to Face Poser. All of these are Episode 2 executables. So we're going to go and find those real fast. We go into our EP2 source folder, go up a directory, and then up another directory, back into Source SDK, like we did earlier, bin, and then you want to find Orange Box, and go in there, bin, and here you'll see the executables like we saw in the EP1 folder. We have Hammer and Face Poser. So all I did was I clicked on Half-Life Face Poser and did send to desktop, created a shortcut. Very simple. And if you scroll down, you'll see vtex.exe and studiomodel.exe. So feel free to make shortcuts to those. It makes it a lot easier to compile quickly. Finally, I want to show you where to find all of these tools. This file you'll find on your support files folder on the DVD. And basically it has all the URLs for the tools that we're using. So with GCFscape and VTF-Edit, they're both located on the same website, nemesis.thewavelength.net. And also you can Google them and they'll come up. The model decompiler you can find on the Noesis Interactive website. And basically if you paste in this path, it'll give you a direct download. And it's a very small file, so it only takes a minute to download. And then there's the mod tool. You can find this on the Softimage website. So it's pretty straightforward. It's the Mod Tool 6. It's really cool, all the features that are in it. And finally, I used a specific hex editor in one of the chapters for the episode 2 decompilation. This is my preferred hex editor, but you know, you don't have to use it. If you have a favorite, go ahead. This one's called XVI 32, and it's freeware, so you don't have to pay for it, but I thought you might want to use this. I find it useful because you don't have to worry about gaps. It puts all the hexadecimal numbers in blocks, so it makes it very easy to modify without messing up. So those are all the links, and you can basically go and get all the tools. So now we're ready. Now that we're set up with our shortcuts, we're ready to begin the tutorial properly. In this chapter, we're going to use GCFscape to extract the Malo2 model and its textures for decompilation. The reason why we need to decompile is to revert the files back to a format that can be imported into XSI via the Valve add-on. In the case of the model, this is the Studio Model Data Format, or SMD, and I'll often refer to it as the SMD throughout the tutorial. And in the case of the textures, this is a target file, or TGA. So let's get started. First off, make sure you don't have GCFscape and Steam running at the same time. This could corrupt your game files. So let's open GCFscape, File, Open, and here you'll see all the GCFs. These hold some or most of the game resources. If you're interested in the Episode 2 models in particular, you can find them under Episode 2 Content. I've decided to use a Citizen for my example throughout the tutorial, but you're welcome to use any model that you want. So let's go into Source Models, Half-Life 2, Models, Humans, Group 01, and then scroll down until you find Malo2. Now Malo2 starts at malo2.dx80.vtx down to malo2.vvd. So now we want to extract them. We're going to go into our EP2 source folder and then into GCF files, and now we're ready to extract. So back in GCFscape, you want to start with malo2.dx80.vtx and then down to malo2.vvd, drag and drop into your GCF files folder. And so that's our model, and now we want to extract our materials. So back in GCFscape, File, Open, Source Materials, Half-Life 2, Materials, scroll down until you find Models, and then scroll down until you find Humans, Male. Now we're going to grab more textures than we need at this point, but we'll be thinning them out later, so don't worry about it for now. We want to grab everything from dark_eyeball_l.vmt down to pupil_r.vtf. So go ahead and grab those, drag and drop into your GCF files folder, and back in GCFscape, let's go into Group 01. Want to grab the citizen sheet, so citizen_sheet.vmt and citizensheet.vtf. Scroll down till you find ted_facemap.vmt and ted_facemap.vtf. And let's select both of these and drag and drop. And we're done. So in the next chapter, we're going to concentrate on decompiling these files. Now that we've extracted Mail02 and his materials, we want to focus on decompiling him. Make sure GCFscape isn't running. Let's start Steam. I'm going to start in offline mode, but if you're connected, that's fine. It's going to take just a minute. Close my window. Okay, and the next thing we want to do is start the model decompiler. I'm using Eric's Fix, but if you're using Cannon Fodder's original, that's fine. You'll notice that it's asking for a path name. It says choose model file, so we need to give it one. Let's go into our EP2 source folder, GCF files, and let's copy the path. Paste it into our model decompiler. Now it needs to know which file to decompile. So let's go back into GCF files, scroll down until we find the start of the Mail02 compiled files. It starts with mail02.dx80.vtx and it ends with mail02.vvd. Since we're here, I'm going to give you a brief explanation of what each of these files contains. The DX80, the DX90, and the SW.vtx are for software rendering. This is the DirectX 8 and DirectX 9 files. Mail02.jpg is just a picture of Mail02. The Mail02.mdl file defines the structure of the model along with the animation, bounding box, that sort of thing. The Mail02.phy file, phys file, is the collision model. And the Mail02.vvd file stores the position data for the bone weights, the normals, vertices, that sort of thing. So now that we have somewhat of an idea of what each of these files are, let's go back into our model decompiler. It needs an output directory, but first off we want to tell it which file to decompile. The decompiler always wants the .mdl file, and if you move or delete any of these 7 files, it will not be able to decompile. So let's keep them together. So back in your model decompiler, type /mail_02.mdl. Now it wants an output directory, so go back into GCF files, up one directory, into your model source folder, Mail02, whatever you've called it, copy the path name, go back into your model decompiler, and choose output directory, paste it in. Now we want to extract. It's loaded the model, that's a very good sign. Hit OK, and now it's dumped it. And you can see in the Mail02 folder the decompiled files. So that's worked. Next we'll be working on decompiling an episode 2 model, which can be a little bit different. So now we're going to focus on decompiling some episode 2 models, because this process is a bit different from what we've already learned. We're going to need a hex editor, and I want to talk about my model decompiler shortcut for a minute. if I go into it, under Properties, you'll see at the end of my command path I have a parameter called -no steam. This I have found has solved the problem with the error the decompiler would throw up. It would say extra app ID set to 211 but no Steam app ID. And it seems to have solved that problem, so you might want to consider setting up a similar shortcut. Now we're going to go into the EP2 source folder, and you'll see I've set up a temporary folder for this portion of the tutorial. It's EP2 GCF files, so if you want to do the same, go ahead. And inside of there I have 3 other folders: the advisor, antlion grub, and dog. And inside each one of these I have another folder labeled decompiled model. So we're going to attempt to decompile each one of these. So let's make sure Steam isn't running. Let's go into GCFscape, then File, Open, Episode 2 Content, EP2, Models, scroll down till we find the advisor, and this time we're going to need an extra file that we didn't need with Mail02. So you want to select everything from advisor.dx80.vtx down to advisor_animations.ani, and we want to go into our advisor folder and back into GCFscape and drag and drop into the folder just like we did before. Now we need to go up a directory and find the antlion grub back in GCFscape. Scroll down, and we want to select everything from antlion_grub.ani down to antlion_grub.vvd. Okay, and we'll go into our antlion grub folder and back in GCFscape and drag and drop. Go up a directory, go ahead and go into our dog folder, and back in GCFscape, let's go find dog. There he is. Okay, so we want every folder from dog.dx80.vtx down to dog_animations.ani, and drag and drop into your folder. Okay, we can close GCFscape because we're done. Now, what we want to do is we want to try to decompile dog first and see what happens. So load up your model decompiler. Okay, and remember we need to put in a command path. So we'll go over to our dog folder, copy that, put that in choose model file, and then at the end you want /dog.mdl because it's always looking for the MDL file, and then go into your decompiled model folder, copy the command path, back in the decompiler, and choose output directory, paste, and now we want to try and extract. And you'll see straight away that it's not even able to load the model. So we have to figure out why. And the reason is because it's looking for a certain game ID and it can't find it. So now we have to hex edit the model file. So if you go back up a directory, with our .mdl file, we want to open it up with a hex editor. So I'm going to do that. There we go. And what you'll see at the very top are the letters I, D, S, T. And in this case, all we care about is what comes after those letters. And we have a dash. Basically, sometimes you'll get a dash, sometimes you'll get a period, sometimes you'll get a comma. What you want is the comma, because that's the game ID. So each one of these stands for a different game, like Half-Life 2, Episode 1, Episode 2, Team Fortress, that sort of thing. So we always want to try and get back to the comma. So let's go ahead and change that. File, Save. Close down the hex editor. And now we want to try and decompile again and see what happens. So we're going to hit Extract again, and it's loaded the model. Hit OK, and it says it's done. So let's hit OK, and we'll go ahead and close the decompiler and go into the decompiled model folder, and there you'll see that the model has definitely decompiled. And while we're in here, I want to talk about the model decompiler.qc file. QC file is known as a Quake-C file. It controls the process of compiling. And if you look inside of this file, you'll see lots of information that we're going to discuss in further detail later. But this is what typically a decompiled model QC will look like. And if this information isn't in there, then most likely it hasn't decompiled properly. Let me close that. Okay, so dog, he worked fine. Let's go try another model. Go up, and we'll go into the advisor. And we already know we need to change the .mdl file. So let's go ahead and hex edit. This time it's a dash. Change the dash to a comma. Save it. Okay, now I want to load up the decompiler. Copy the path back into the decompiler. Then /advisor.mdl, and then back into our decompiled model folder, and paste into our decompiler, and then we want to hit extract. It's loaded and it is finished. You'll notice something, hopefully straight away, that the QC is much smaller than Dog's. Dog's was 10, this one's 1. If we open it up, you can see that it hasn't decompiled properly, at least not all the way. It hasn't extracted all the information that it needs. But if you are apt with working with models and building your own QC, you can still make this work, because you have the mesh, you have the basic model, you just don't have the QC information completely. So now we're going to try one more model and see what happens. We're going to go to the antlion grub, and we're going to alter the .mdl file, hex editor, and this time we have an O. We want to change that to a comma, just like before, and save it. Close down the hex editor. Now we want to copy our paths across. And then decompile model folder. Copy our path across back to our decompiler. And now we want to make sure that in our choose model file that we have /advisor.mdl. Always want to make sure you do that, or else it won't be able to decompile. And we're going to hit extract. And it says it's unable to load model. Oh, that's because I've typed in the wrong name. It's antlion_grub. Sorry about that. And we'll hit extract. Okay, it's loaded the model. And you will see straight away that it has crashed, and that's what I expected it to do. Of course, the decompiler can throw up different errors each time. It's just having a difficult time decompiling these episode 2 models. And you'll notice that we have absolutely no information in our QC this time. But what we do have, and is a bonus, and it's a testament to the decompiler, because it is a miracle that it still works with episode 2, we have the mesh. And I just want to show this to you quickly in XSI. So if we load up XSI, And we're going to be doing this later. We're going to be explaining this whole process of loading up models and bringing in the texture paths and all of that. But this is just to basically demonstrate the decompiler with episode 2 models. So we'll be going into this in further detail. It's going to take just a minute. Okay, I'll minimize, get rid of this window. So don't worry about what I'm doing right now, because we're gonna go into it in further detail. But if you want to follow along, that's fine. I need to minimize XSI, and I need to copy the path out of the decompiled model folder, and I need to go back into XSI, and up where it says valve source, I need to import the SMD. Control V, paste it in, open up this, and then it always seems to be up a level even though you tell it not to be. And we want the grub_reference.smd file. Okay. Won't worry about the textures right now. So here we go. We have the model, we have the mesh. Put shaded on so we can see. And there is the antlion grub. So even though you don't get the QC information, you at least have the model, and that's really a big deal. But we're going to be talking more later about QCs and textures in depth, so we'll be looking forward to that chapter. Now that we have our model decompiled, we want to focus on decompiling our textures. We're going to use a program called VTF-Edit to do this. It's going to convert the compiled textures back into TGA files or target files. Open VTF-Edit. At the top, you'll see many options. We want to select Tools, and then Convert Folder. Now we need to navigate to our Input folder. That's our GCF files folder. So mine is in Program Files, Steam, Steam Apps, then my username, Source SDK Content, EP2 Source, and then finally select GCF Files. Hit OK. And then my output folder is going to be in Mail02. So C, Program Files, Steam, Steam Apps, your username, Source SDK Content, EP2 Source, Material Source, Mail02, and then hit OK. Now make sure you have 2 TGA selected, so we're going from VTF to TGA. Leave the defaults and hit Convert. And you'll see the progress bar, and it's finished. So now we can close the window, close down VTF-Edit, go into the EP2 Source shortcut, Material Source, Mail02, and you'll see all our TGAs. Next, we're going to work on bringing our model and our materials together. In the last couple of chapters, we focused on extracting and decompiling our model and materials. In this chapter, we're going to focus on getting that model and those materials into XSI. So let's get started. Go into your EP2 source folder, Model Source, Mail02, and inside we have our decompiled files from earlier. I'm going to give you a brief explanation and overview of these files. We have our level of detail models. Basically, they're lesser detailed models used to enhance performance because you don't always want the high-res model, especially when you have a lot going on in the game. So these kick in when a certain threshold is reached. Underneath those, we have the mail_02_reference.smd for our purposes, we're going to look at this as the actual model. In a very simplistic view, that's how we're going to look at it. Underneath that, we have the MDL decompiler.qc or QuakeC. It's a text-based scripting language, and basically we're going to look at this file as the control center for all these other files. It's what tells the compiler how to process. Underneath that, we have the MDL decompiler underscore expressions.vta or vertex animation. This is our flexes, our expressions and face poser. Underneath that, we have the fizz model or the collision model, and below that we have basically the ragdoll. So these are our files, and the one we're going to focus on in this chapter is the mail02 reference.smd. So we want to import that into XSI, but we have a problem. If you open this file, I'm going to open with TextPad. Feel free to use whatever program you want. If you scroll down, you'll see one of our textures here. This is ted_facemap.bmp. The problem with this is that the extension is wrong. If we loaded this into XSI, XSI would look at our materials and it would want a .bmp extension. Well, our material files at the moment have a .tga extension. So in order for XSI to see that, we have to change this extension. The other way you could do this is you could load up the TGA files in a paint program and convert them to BMPs. But I've found that it's much simpler just to search and replace. So I'm going to search, replace, and I want to find every .bmp and replace with .tga. So replace all, okay, and save, and close it down. So now we're ready to import into XSI. Let's just minimize this window for a minute because we're going to be coming back to it. Let's start up XSI. This is going to take a minute. Okay, get rid of NetView. Now you need the Valve add-on installed, otherwise you can't do this. As you see, I've got something called Valve Source up here. So if you click on that, we're going to import an SMD, and you can see that we have the it's wanting the import file, so we need to give it a path. If you go back into your mail02 folder now, copy the path, minimize, and then back into XSI. You want to paste that path, click on the little 3 dots here at the end into your mail02 folder, and then select your mail02 reference.smd, this file, click OK, and now we need the textures. So for ease, I'm going to use the same path I just pasted up here. I'm going to paste it in my texture path. It's wrong, so when we go into the directory, we need to go up to and then into material source, mail02, and just hit select. You don't get an option for files, just the folder. Make sure you have import materials checked, and then hit OK. And let's get the first look at our model. Here he is. I'm going to put shaded on so we can kind of see his shape. There's his shape. And then let's do texture decal. And there's our citizen. Okay, in the next part, we're going to work on fixing some problems and artifacts left over from decompilation. In the last chapter, we focused on importing our model and its materials into XSI. This is because we want to rig and weight map him and ultimately get him back into the game. But before we can do that, we have to talk about a few problems we have because of the decompilation process and because we've imported the model in from another program. The first problem we're going to deal with is the artifacts left over from decompilation. So if you bring up Explorer, which is 8, you'll see something called Valve Biped. This is our 3D model. We have to get rid of this because when we try to rig, it's going to try to create another Valve Biped model, and if you have 2 of them, it won't allow you to rig. So this is a duplicate, and we need to get rid of it. If we expand this, you'll see something called BIP01 pelvis. This is basically a bunch of nulls left over from decompilation, and if we put our model in wireframe, you can see them. I'll highlight them all. You can see all of them. We don't want these because basically we'll end up with a duplicate and it could affect the model. So we're getting rid of everything that could potentially keep us from rigging or cause problems at the end. Let's go down to the mesh. Now this is what we want. Let me put it back in texture decal. We're aiming to get just the mesh. This is the starting point for us. We don't care about all this other stuff up here. It's just extra and we need to get rid of it. If you go underneath the mesh, let's expand that, and then polygon mesh, go down to clusters, you'll see something called envelope weight clusters. This is basically a leftover weight map. If I click on it and then go visibility into, let's see, I want to pick on the weight points, and deselect, you'll see the leftover weight map. And it won't cause a problem. It'll rig fine and everything, but you'll end up with 2 envelope weight clusters. And you don't want that. You don't want to have to deal with extra information that you don't need because it can potentially cause you problems later on. So the first thing we're going to do is we're going to delete the envelope weight clusters. So middle click, press delete, and we've taken care of that. So let's look at the mesh here. Basically, our mesh is called mesh, and this isn't a very good name for it. I'm going to rename mine to something more appropriate. As if I've created this model myself, I definitely wouldn't have called him mesh. So I'm going to right click, rename, and I'm going to call mine Kevin. You can call him whatever you like. And now we have a better name, and I will refer to the model as Kevin later on in the tutorial, just so you know what I'm talking about. So now we have Kevin here. We want to separate him from the Valve Biped hierarchy. So middle click on Kevin. Under Constrain, you want to hit Cut. Now he's in the scene root. And the last thing we have to do, which is very simple, is middle click on Valve Biped and hit delete. And we are basically starting from scratch now. And this is where we want to be. This is the point we want to be at. But let's close this. We still have another problem we have to deal with. Okay, let's put the model in wireframe mode. Down to wireframe. If you click on the mesh, you'll notice these blue lines all over our model. Basically, these are double edges, and when you import a model from another program, XSI interprets the polygon normals wrong, and you end up with a hole in your model. You end up with 2 normals pointing in different directions. So we have to fix this. We basically have to weld those edges back together. If you look at if you go into visibility under normals, I'm going to put shaded on. What you see is that wherever you have a white line, no double edges, you have one normal, which funnily enough is normal. And wherever you have a blue line, you have 2 edges pointing in opposite, 2 normals pointing in opposite directions. And what this does is it creates a hole in your mesh, and you don't want that. And I've seen people go through the whole process of weight mapping, rigging, flex animation, the whole works. They get the model into the game only to find out that there's a big gaping hole in it. So we definitely want to get rid of this problem. And this isn't a unique problem to just Valve decompiled models. This is any model from a different program. So I just wanted to make that point clear. So now what we want to do is we want to turn the normals off, and we want to get rid of these double edges. Now I want to point out something real fast here. The neck is a particular problem because when it decompiled and imported in, it made a big gaping hole in the model. The thing about the citizens, they're a little bit different from other models. What I believe Valve did is they had the head detached from the body, and that's how they interchanged the heads on the citizens. If you think about it, the citizens all have the same body. All the males do and all the females do. So I think for ease, they just kept the head separated. Well, this has caused a problem for us, because I know if you import Alex or Magnuson, the head's welded. This doesn't happen. We have to make a decision at this point, and it's entirely up to you. You can select points. Let's go into Raycast. You can select a point, and you can drag it down to a point in the mesh where basically if you animate it, the hole won't occur. It'd be back down to the same point that Valve had it. I'm going to undo that. Or my method is to go ahead, because I'm not interested in switching out the heads, I'm going to go ahead and weld the edges back together. So I'll deselect that. So let's talk about the weld edges operator for a minute. Before we actually weld the edges, we need to understand some of the options in the weld edges operator. So select your model and make sure you're in modeling mode, and under modify you want to select poly mesh. Go down until you find weld boundary points / edges and select, and there's our weld edges operator pop-up box. Let's discuss the options within it. Let's start with distance. Distance controls the tolerance, so the more you increase this, the more edges you affect, and you can get wildly varying results. And target specifies which edges to weld. So the choices you have are the input edges, the other edges, or all edges. Input edges weld selected edges with each other. Other edges weld selected edges with other edges. And all edges welds all the edges. So that's what they do. I always leave the defaults. Feel free to do what you want, especially if you have a lot of experience at this. For our purposes, we're just going to leave the defaults. So close the box, and under Edit, up at the top, we want to do Undo Weld Edges, because it did weld them for us, but it didn't do it correctly. And now we want to point out some potential problems. We already discussed the gaping hole under the neck, but let's look at the hand for a minute. As you can see, these 3 fingers are welded together, but this isn't because of anything we did. This is just how the model is. This is how the original mesh was designed. So don't think that when we start doing this that we've done something wrong, especially if you decide to do this a little bit at a time, because you don't have to use my method. And I recommend welding a little bit at a time when you first get started, just to get familiar with your model, because we are changing the mesh slightly. So I think it's important when you start with a new model to just go through it a little bit at a time. Let's go back up here. Now we're going to get started. The first thing we want to do is we want to go back into Explorer, and then under Kevin we want to go into Polygon Mesh and then Clusters, and then where you see Mouth you want to select it. We want to right click on it and hit Select Components, and then we want to press H or hide. We don't want to change the teeth, and basically that's what we were looking at. If you look here, we're hiding the mouth because we really don't want to change the edges on the teeth. It completely screw them up. So now what we're going to do is we're going to filter out everything else and just concentrate on our edges. So under Select, hit Edge, and then on the drop down box you want to select Border Edge because a double edge is a type of border edge, and then press Ctrl A, and now we have them all selected. We have to deselect the neck edges because they're a different problem altogether. So if you do Select, Tools, Raycast, and let's get close here because it is a little hard to visualize this the first time you do it, and I might screw up as well, so don't take it personally. Let's start deselecting the neck edges. Hold Control down and just start clicking on them. You want to make sure you get them all, otherwise you're going to end up with a weird weld, and that's not what you want. Don't get his collar here. We don't want that. Let me scroll around a little bit. Scroll around a little bit more. Okay, and we gotta get the top one. Sometimes it's, like I said, it's hard to see. Okay, keep scrolling around. Right. So we have it all selected now. Just the neck. So what we're going to do is we're going to go actually weld the rest of them. And this won't work for every model. Each model is separate. It's a separate problem. So keep that in mind, that if you import another model, this isn't going to work for it. You have to try different things, different edge types, and it's just trial and error. So let's go under Model, Modify, Polymesh, down to Weld Boundary Points / Edges, and we want to select all edges because we want to weld all of these edges. And what's going to happen is, let's close our box, let's deselect, let's go into Shade It. All the blue lines are gone. All our edges are welded. Let's just check the fingers, make sure our index finger isn't welded. And you need to make sure that if you do this method that all the edges are definitely welded except for the neck. Okay, so now we're going to weld the neck. The reason why this is a bit tricky is because the edges are so far apart. Like I said earlier, you could use the other method of just pulling the points down, making sure you don't have a gap in the mesh, but you need to make absolutely certain. Otherwise, when you animate, you'll get a hole, and you don't want to get to that, do all this work just to find out you have a hole in your mesh. So let's select our model. And the reason I chose to show you this method of welding is because you'll find it useful with other models, especially ones that have large gaps. Let's go into Wireframe and then select Tools, Raycast, and then also under Select Edge, and then in the filter we want Border Edge. Now I'm going to do this a little bit at a time, instead of selecting all of them at once, because it won't weld properly. You just have to, this really is one of those situations where it's trial and error, and I may mess up a bit as we're going, but I'll try to get it right the first time so that we have some continuity. So let's get started. We want to start at the front of the neck here, and we're going to select these 3 edges, and then we're going to go Poly Mesh under Modify, Weld Boundary Points Edges, and there you'll see that we have a nice clean line. So we want to leave that alone. And now we want to go over here to the other part of the neck. Let's try these 3. So middle click to get it to do it again. And let's raise the tolerance on input edges. And now what we want to do is we want to go back into texture decal just to make sure it's an acceptable weld, because you can get the polygons doing weird things, so you need to make sure that you're happy with that before we continue. And that looks pretty clean. So now let's go back into wireframe, and let's go over here to this side, select these 3, and let's hit Poly Mesh, middle click, and that looks pretty good. Now there's a really large gap here, and this can be a bit tricky, so I may have to do this a couple of times to get it just right. So let's select our lines, and I'm going to select a few more this time than we did last, and let's middle click on Poly Mesh, and you can see that we still have a large gap, and if I was to click off right now it would be blue lines. It hasn't welded. So let's try the tolerance first. Okay, and there we go. We have a nice clean edge. And now what we want to do is we're going to go into texture decal and zoom out and see what you think about that. I think that's pretty good. I think that's pretty clean. Let's go back into wireframe, and over here let's select these 3. Let's try that, and then middle click Poly Mesh. Okay, let's try the tolerance, and there we go. Let's just check that real fast. Go into texture decal. Let's go back at the back of the neck and kind of look, make sure there's no bulging gaps or anything. You can see the red line down there, and I think that's pretty good. That's a pretty good clean edge. Let's go back into wireframe. This is a bit fiddly, it really is. And this time let's select okay, this may or may not work, because this, like I said, anytime you have a large gap it is tricky. So let's middle click on Poly Mesh, and I think we got a pretty clean line that time. And then let's just do these 3. We had one left over, it didn't weld because it was too far away. And let's middle click Poly Mesh, and it hasn't welded yet. Let's try the tolerance. Okay, let's set this back to 1. Let's just select these. It's not going to work. And all edges has worked for us this time. So like I said, sometimes it's just a bit trial and error to get the result you want. So let's put texture decal on, and he looks pretty good. Let's zoom out, look at our model, and no more blue lines, which is great. So no more holes. So in the next chapter we're going to focus on rigging and weight mapping. In the last chapter we fixed our model, got rid of the superfluous bonds and double edges so that now we could rig and weight map, and finally export and compile. What we want to do first is make sure that we're in the animate mode, and before we rig we need to bring up Explorer, which is 8. And if you remember, we hid the mouth in the last chapter, so we need to unhide it. So you'll see Kevin here, and the little H for hidden. So if you expand, Polygon Mesh, Clusters, click on the mouth, and press H, and it'll be unhidden now. So close that down. Select our model, zoom in on him, and let's put him in wireframe just to make sure. There's the teeth and the mouth. Okay, let's put texture decal back on. Now what we're going to do is we're going to rig the model. So click on the model, valve source, character rigs, biped guide. Now you want to make sure, you want to go back into Explorer, make sure the valve guide is fully selected. Branch select it with the middle mouse button. Let's minimize that. I'm going to go back to valve source at the top, character rigs, rig from guide. Here comes our rig. It'll take just a minute. Okay, you can close all the windows down. We don't need those. Go back into Explorer, 8, and where it says Valve Guide, middle click, and delete, because it's just going to get in the way at this point. Okay, let's close our window down. Now that we have our model rigged, I'm going to set the envelope. I'm going to demonstrate this technique first, and then I'm going to show you another technique concerning the weight map. So let's go ahead and do this as normal. Bring up Explorer, 8, and expand Valve Biped, and you're going to go down and you're going to see something called Envelope Deformers. This is what we're going to use to set our envelope. So if you click on the model, and then make sure you're in animation mode, under Deform, Envelope, Set Envelope, and it's going to ask you, do you want to apply it as an animation operator? And you're going to say yes. And then it's going to want you to pick, there's a pick session. So back down where I showed you the envelope deformers before, you want to middle click, branch select, envelope deformers, and then right click. And there's our weight map. Now at this point, you could set the number of skeleton objects to 1, which kind of helps with the weight mapping between joints, but it's entirely up to you. So let's close that window, close down Explorer. Before we can start weight mapping, the first thing we have to do is set a neutral pose on our model. Otherwise, every time we move an arm or hand or neck or whatever you move, you'll lose your neutral pose. So it's very important that we set this first. So go into Explorer, and under Valve Biped, expand, and you'll see under Character Controls, we want to branch select everything from BIP01 down to upper body parent. So all of our controllers are selected now. So let's minimize that for a minute. Now we want to go under, make sure you're in animation mode first, and then under Actions, Store, Transformation, Current Values. And here you'll see something called Stored Static Pose. So this is his neutral pose. I'm going to leave it called Stored Static Pose, but you can call it whatever you want. And then just hit OK, leave the defaults. And now, let's zoom out on our model. Let's deselect all the controllers. Let's move his arm. So we've moved his arm. Let's go back into Explorer, and then under Valve Biped, expand, and then under Mixer, expand, Sources, Animation, Stored Static Pose, click on that, and then over, under Actions, and Animation Mode, hit Apply Action. And you'll see that he goes back to his default position. So it's important that we set that, because our default position would be messed up and our animations would be messed up. Okay, let's talk about the weight map, the default weight map on this model. The weight map is a good starting point, but it does leave a lot to be desired. I personally don't like weight mapping, but it's a necessary evil, and so we have to do it. Let's go into visibility, weight maps, and then click on the model, and then we want to select hidden line removal. And here you see the weight map. Now, if I'm moving around, let's just look at some problem areas. You can see here how that's bulging, and you don't want that to bulge out from his chest, so we'd have to fix that. So undo that. Another problem that we have is when we move this arm here, you can see that the elbow really isn't defined very well. It should be more, there should be more of a fold here. And it's anytime, let me put this in wireframe, anytime you have two bones joining, you don't quite get, with this default weight map, you don't get a good blend. So that's what we have to do. We have to go through and blend all the bones until we get a satisfactory result. And some of these problems are easier to fix than others. I personally find the shoulder problematic. It always gives me a lot of trouble. But it's just trial and error. And with weight mapping, the more experience you have, the easier it is. The good thing is, when you're working with the Valve human models, they're basically, their weight map is all very similar, if not the same. Especially with the citizens, it's always going to be the same on the male model. So this weight map, which you can find the completed one on this in the support files folder on your DVD or within the zip file you download it, you could use this weight map on other citizens. Or you could at least do what I do. Let me go into weight mode here, and then I'm going to select point, and then raycast. I select groups of points. This is my method. So I'll select, a row of points all here on the shoulder, for instance, and then I'll go in the weight editor and I'll check and make sure that the right bones are attributed to those points, and then I'll start playing with the numbers. This is just how I like to work. Everyone has a different way of doing this, but it's just up to you what you find works for you. And with these models, you'll find that really that's all about percentages. Like down here in the elbow, let's bend the model. Down here in the elbow, where the elbow's not well defined, you'll find that really it should be about 50-50 all the way around. So this is just things you learn with experience. I'm not going to demonstrate weight mapping because there are already Noesis tutorials on the subject, and it's too lengthy of a process. It's a tutorial in its own. So, but I am just going to, point out some problems here. Okay, now that I've showed you the default weight map and some of the problems associated with it, I'm going to show you what I use for a starting point with the weight map. So let's go out of weight paint mode, straighten our model up a little bit, put texture decal on, and get ready to do this process. Okay, let's minimize this XSI. Let's open up a new XSI, and it'll take just a second. It's going to load up NetView. Okay, it's a little bit slow. Now, we're going to minimize this XSI. Sorry for all this minimization. we're going to go into our EP2 source folder, and then we're going to go up one directory, HL2, model source, humans SDK, XSI scene files, and then we want to bring up our XSI again, and we're going to drag and drop the SDK mail reference onto this XSI. Don't want to save it. We can go ahead and shut down that window and maximize this one. And here you'll see the SDK mail reference. Let me just put shaded on. And what we're going to do now is we're going to click on him. And you see he has a weight map, but it doesn't look like he has a rig. But actually he does have a rig. If you hit display, unhide all objects, there's his rig. Now we want to look at the difference between this rig and the other rig. All I can assume is the reason why there's a difference is because Valve decided to make a new one, and we have the latest version. So I'm going to put this in wireframe, and here you'll see these boxes. There's two, and there's one here and one couple up here in the shoulders. If I click on one, this one's called the pectoral, and there's two of them. And then if I click on the one in the shoulder, it's called the trapezius, and there's two of them, and these are all over the rig. The problem is we don't have these on the rig that we're using at the moment. They're simulating muscles that just don't occur in the rig that we have. And if we go back into our model that we've been working on and put him in wireframe, you'll see that those boxes, those muscles, just do not exist. So we're going to get a variation in the weight map. It's going to try to map it the best that it can, but it's not going to be perfect. But personally, I find it a better starting point than working with the default weight map. But we'll see what you can make up your own mind about which one you prefer. Okay, let's minimize this window. And minimize this window. These two XSIs, minimize both XSIs. Go into EP2 source, and I have a folder called exported weight map. You can make one if you want. It's just to keep things tidy. We want to copy the path. Go ahead and minimize that window. And then go back into the XSI that contains the SDK mail reference. We're going to export as weight map now. Click on the model, and then Valve source, export weight map. And here you'll see I already have the path in, but go ahead and paste your path. And then here I am in my folder, an exported weight map. And then I'm going to type in a name and give him a name, SDK mail. That's fine. Hit OK, and then OK again. And now his weight map is exported. So I'm just going to minimize. I'm going to go back into the model we've been working on so far. And what I'm going to do at this point is I'm going to load up a model that I have for an example to this tutorial, because this guy's already weight mapped and I need him before he's enveloped. So you won't have this, but if you could just follow along so you understand the process. I'm going to open him up, and basically it's just going to take a second. It's taking a little bit longer than usual. Okay, there he is, and this guy isn't weight mapped, and that's how we want him. We don't want him weight mapped. So I'm going to go Valve source, import weight map, and paste my path again, and then EP2 source, export it weight map. Here's the weight map. I'm going to hit OK, and then OK again, and it's going to envelope to this weight map. It'll take just a second. There's the envelope. If you get any errors, don't worry about them. It's just trying to find controllers that it doesn't have. So we're going to look at this weight map real fast and see how it's deforming. And I think, it's pretty good. You can see he's bending pretty well, but it does come with its own problems. If I go over here and I move his arm, you'll see that his arm in this spot is not connected to the bone. So we have to connect it, and I'll do this real fast just to show you. And go into weight paint mode, select point, and then I'm going to just select all the points around his arm. And keep selecting them, and then I'll go to the other side here. Okay, and get that last one. Alright, so I got them all. Now I'm going to hit local reassign, and I pick the bone and then right click, and now you can see that the arm is attached to the bone, the part that was missing, and if I did just move it around, you'll see that you get pretty good deformation, especially in the shoulder, which always gives me problems. I think that's really quite good. The elbow is still problematic, but it's not as bad. But you can see it's a little bit more well defined than in the other rig. So basically, this is another option for you for a starting point if you want to start here. What we're going to do in the next chapter is we're going to look at exporting our model finally and getting him back into the game. Okay. We're getting ready to export our model. It's been quite a journey to this point. We've fixed the border edges and rigged and weight mapped, so now we get to export. This is a very simple process. One thing we're also going to do is create the level of detail models. Although they're not essential, they're basically lower polygon models that are used to approximate the full model when viewed from a distance. They help gain performance, so some of you might find this useful, and they're also very simple to create. But what we're going to do first is simply export our full polygon model. So if you minimize XSI and go into your EP2 source folder, you'll see that I've created a folder called Exported Model, so go ahead and feel free to create that. Go into your Exported Model folder, copy the path, minimize the window, go back into XSI, up at the top, click on Valve Source, Export SMD, paste in your path. I'm going to repaste, and under File Type, make sure you have model.smd selected. So file type model.smd. Leave the defaults. Okay, go into your exported model folder and let's name him. I'm going to call mine Kevin, of course, and then hit OK and OK again. Right, so now our model's exported, and that was a very simple process. Now we're going to create the level of detail models. So first go into View and Selection Info and select your model, and you'll see that he has currently 4,732 triangles. As we create the level of detail models, this will reduce. You might also be interested to know that you can reduce selected parts of the model if you want it. You could select all the polygons in the head and reduce the head, but we're going to reduce the full polygon model and complete. So make sure you're in modeling mode, under Modify, Polymesh, and you want to find Polygon Reduction. Click on that, and here you'll have the Polygon Reduction operator, and you can see that there are several options. We're going to go under LOD controls, and you want to select Use LODs, and under Reduction Ratio per LOD, type in 25, and then under Activate, which is under Control by LOD Stage, Activate, select that, and you'll see that we have something called LOD stages. We're going to do 5 of them, and each time it's going to reduce the full polygon model. So we're going to start with number 1, so slide it to 1, and then simply go up to Valve Source, Export SMD, and make sure you have model.smd. Let's call it LOD 1. Hit OK, then OK again. can see it's reduced already. And then at LOD stage 2, let's export again. And then type in LOD 2. OK and OK. This isn't the most exciting thing in the world, but it's necessary. Then LOD stage 3, valve source, export SMD, LOD 3, LOD stage 4, valve source up at the top, export SMD, and then LOD 4. OK and OK, and LOD stage 5. Finally, valve source at the top, export SMD, call it LOD 5, hit OK and OK, and we are done. So we've reduced our model and we've exported the full polygon model. So what we're going to do in the next chapter is we're going to bring everything together in our QC. So I'll be looking forward to that. Now that we've exported our model and our level of detail models, we're ready to focus on the QC. So open up your EP2 source folder, and then inside we have the exported model folder that we created in the last chapter. If you open it, you'll notice inside that we have a lot more files than we had in the last chapter. Last chapter we exported the Kevin.smd and our 5 level of detail models. You can find these files are necessary for correct compilation of the model. You can find them in your support files folder on the DVD, and you simply just drag and drop that into your exported model folder. So you don't have to worry about going and getting them. But in case you're interested and you need, for future reference, let me show you where I got them. Let's minimize this window, and I'll open up the EP2 source folder again. Up one directory, HL2MP, model source, humans SDK, and here are some of the files that I have that I need for compilation, and then inside the mail folder are some others. And so you have all of these bundled, so I don't need to go through them, but there they are for future reference. So I'm going to close this window now, and I'm going to go back into the exported model folder. And what we're going to focus on really is the QC. That's all we care about. So let's go ahead and open that up. And I've annotated it to make it easy to sort of follow along and to understand it. So at the top we have model name Kevin.mdl. This is the name you will find in the episode 2 directory when you go to look for the model. It's the compiled model name. And underneath that we have CD materials Kevin. This is the material path. This is where it looks to find the materials to apply to the model. We haven't discussed that yet, but in the next chapter we're going to cover materials, so don't worry about it for now. Underneath that you'll see that I have comments, a bunch of comments concerning the materials used on the model. I got these from the decompiled QC, and basically these are all the materials the model uses. And if you remember at the beginning of the tutorial I had you extract several textures. Some of those textures you don't need, and what you can do is you can use this information to weed out those textures you don't need, and we're going to do that in the next chapter. So this is very useful, and you can always get that whenever you decompile a model out of the QC. Underneath that we have model Kevin SMD. It just specifies the reference SMD. This is the model we exported from XSI in the last chapter. And then we have the flex file Kevin expressions.vta. This is the vertex animation. This is the thing I had to recreate to get his flexes working correctly again. That's in FacePoser. You'll see an example of that in FacePoser. And then I have include standard flex XSI, it defines the flex frames. So like frame 25 is byte, and that's all it does. It just tells PhasePoser which frames are what. And then below that, we start the eye and the face data. This information contains the eyeball position, the textures, and the pupil scale. This is like the parent bone, and beneath that you have the, it's using the vertex animation for the eyes to tell them to blink and close and that sort of thing. If you're interested, the frames are always 1 and 3, 2 and 4. So this is basically just all of this is just the eye information, and that's all you need to know about that. Below that, we have the mouth illumination, and then we have include Kevin face rules.QCI. These are the flex equations. They're very complicated, but they are what sometimes blend the shapes together. So like, you know, this is what makes him smile, and that blends several different shapes together to make him smile. So these are mathematical equations that basically control the flexes. And then we have include the body rules. This is the body flex controllers for the range. Underneath that, we begin the level of detail models. So we have like LOD 7. In case you're interested, the 7 is the distance in which the model will appear. So at 7 meters, this model will reach it'll basically kick in, and it'll replace our Kevin.smd with our level of detail model 1. And it'll keep doing this, so on and so forth. At LOD 14, for instance, it replaces the Kevin SMD with the level of detail model 2, and it removes the hands, because you don't need that level of detail at that distance. It's not something you're going to notice. And so it keeps doing that and replacing things and lowering the polygons. And then we have the shadow LOD. And basically I've used the level of detail model 4 for the shadow because it doesn't need to be a high polygon count. So you can do that. You can just take a level of detail model and use it for the shadow, or you can create a custom one. It's up to you. And then below that we have the attachments. These are the hook positions for things like weapons. And you can create more of these if you wanted by using certain parts of the skeleton. So you could create a hook just about anywhere. And below that we have the eye position. And then we have include standard hierarchy. It's the hierarchy of the bones. And then we have include standard IK chains. It's the rules for how the bones behave. And always collapse male 01. It always collapses the name bone no matter how it is used. Always collapse the XSI scene root. And procedural bones, the male.vrd. It's the helper bones that help control bone orientation and position. And then we include the common bones. It makes sure none of the bones or attachments of the rig get lost during compilation. And that's obviously very important. Otherwise it'd be a bit of a disaster. Underneath this, we have something you might be interested in. It's the include model command. What it does is it's used to add an MDO file so that other models' animations can be used as long as the skeleton is the same. So to our citizen, these at the top, the humans male shared, humans male SS, the humans male gestures and postures, those are your basic citizen animations. But you'll notice that I have Barney underscore animations and Magnuson and Kleiner and Breen. What that means is that I've added their animations to my citizen, so my citizen can now do Barney's animations or Magnuson's. And so you can adding this adds to your animation library. You can also add the female animation, so you could have Alex postures or Alex gestures, and I'll show you an example of that later. Sometimes when you add the female animations, you get a bit of a clipping problem on certain animations, but generally speaking, you can end up with, you know, all of the animations at your disposal. So that's a lot of fun. Underneath that, we have the surface prop, which is flesh. It affects the sound when hit. We have the illumination position. It sets the illumination position of the model. Very self-explanatory. We have include the hitbox. It approximates body area where the model can be shot. And then we have include the ragdoll. And that's a collision model with special low polygon mesh with loose joints and simplified weight map. And I think it's a very cool model because the joints aren't rigid. So this is our QC in a nutshell. And if you don't understand some of it, don't worry about it, because it's all put together for you and the model will compile correctly. So in the next chapter, what we're going to do is we're going to focus on our textures and getting the paths correct so that our model can use them. In this chapter, we're going to look at textures and compiling them and making sure that the path is correct so that they can be applied to the model. If you remember in the last chapter, we looked at the QC and all the files needed to make that up and to get the model to work correctly. Well, textures are part of that. We're going to be using the Episode 2 VTex Texture Compiler. That's the Valve texture tool. It converts the TGAs into the VTF format, which is the compiled format. I've already got Steam running just to make it a bit so you didn't have to wait for it to come up. So if you don't have it running, you need to have it running to compile. I'm going to go into my EP2 source folder. And if you remember, we made a folder called Material Source early on in the tutorial. I had you extract the materials into this folder. So now we're going to look at them. And they're in Mail02, and here are all our textures. Now, we don't need all of these textures. I had you extract more than you needed because just to make it easy. It's easier than saying each individual texture. So the way we find out, you know, we want to weed it out. We don't want to keep all of these and clutter everything. So the way we weed it out is we open up another, go into your EP2 source folder, again, open up another window, and go into the exported model folder, and open up kevin.qc. And inside here, if you remember, I told you that there was some comments in the QC that told us exactly which materials our model was using. I pulled this from the decompiled model QC. That's where I've got this information in case you're wondering. But you can see that it says model uses material, mouse, eyeball, that sort of thing. So what we want to do is we want to go back into our Mail02 folder and we want to correlate this information and just have the textures that we need and nothing else. So the first one in the QC is the mouth.vmt. We're going to go over into our Mail02 folder, and there's the mouth, the TGA file, because it's not compiled. We need eyeball left and eyeball right, which we have, but we also have the dark eyeball, and we don't want this. So select the dark eyeball and the dark eyeball left and right, and just delete those. And then we have TED face map, which we have in our Mail02 folder. We have the citizen sheet, which we have. We have pupil right and also pupil left. But if you look in our Mail02 folder, we have the green pupil right and the green pupil left. We don't want those. So just select those and delete. Okay, if you go back into the QC, we also have something called glint. So let's just make sure we have that, and we do. So we have all the textures we need to compile now. So we can go ahead and shut down our QC and just leave the exported model folder window up for now because we're going to need it in a second. We'll just minimize. Okay, so the next thing we have to do is we have to compile these files. And before we can do that, you need to go up one directory. And you see where it says Malo 2? If you remember, we told in the QC, we said that it was under Kevin. So this folder needs to be called Kevin. So let's just rename. We'll call it Kevin. You want to give it something descriptive, because otherwise you can get really confused with what you're working with. So it makes sense to always name it after the model. So now what we're going to do is we're going to go into the Kevin folder, and we're going to compile these textures one by one. We're going to drag and drop onto the VTX texture compiler, and a little window is going to pop up, and it's basically telling us that it's compiling it. And then let's do the eyeball. Some of them compile faster than others. And glint. And mouth. And pupil. And just keep going until you get them all. And finally, TED face map. Okay, so now we have all our textures compiled. The next thing we need to do is we need to go up a directory, up another directory, and then where you have GCF files, you want to open that up, and you'll see that we have all the decompiled VMTs. Basically, this contains, in a very simplistic form, the texture path and the shader information for each material. We need this in order for our model to be able to find the textures. So if you go into the exported model folder that we minimized a minute ago, if you go up a directory, up another directory, and up yet another directory to Half-Life 2 Episode 2, to that folder, you want to go in there, and then you'll see EP2, and inside of here you'll have two folders, one called Materials and one called Materials Source. If you don't have both folders, don't worry about it, but you should have a Materials folder. And inside of there you'll see that we have our Kevin folder, which contains all of our compiled textures. Now, in order for those compiled textures to be found, we need the corresponding VMTs. So what we're going to do is we're going to take the VMTs that were from the decompilation, and we're going to move them over. So back in GCF Files folder, you want to click on the Citizen Sheet, Eyeball Left, Eyeball Right, Glint, Mouth, Pupil Left, Pupil Right, TED Face Map. And I think that's all of them. You can just double check. You want to drag and drop them over into our Episode 2 folder. And you can go ahead and close down the GCF Files folder. And here in our Kevin folder, you'll see we now have our VMTs along with our VTFs. We need to open up these VMTs because they don't have the correct path. So the citizen sheet.vmt, go ahead and open that up. And you'll see that we have this long path. This is the original path that the model used. And that's no good for us because it won't find it for our model, and it'll overwrite your actual Malo 2 model in the game. So we need to change this. So keep the citizen sheet at the end, and everything before that you want to delete. And you just want to put Kevin. So you'll have Kevin /citizen underscore sheet, and then you just save, and that one's done. And we have to do each one, and let's just put Kevin, and the same for the next one for the pupil, and save. These are their eyes, and then eyeball right. Want to do the same yet again. It's really quite straightforward at this point. And save. And then the glint. And the mouth. teeth, and then the pupil left. This is our eyeball, and the pupil right. Save it. Use Control S to make it faster. And finally Ted face map, which is his face. And just save that. So now we're done. We have our compiled textures and our information so that those textures can be found and applied to our model. So in the next chapter we'll compile our model, and then we're on our way to actually seeing the model in Phase Poser and then eventually in the game. Welcome back into the last chapter of the tutorial. Previously we compiled our textures, and before that we extracted our model, decompiled it, fixed it in XSI, and then exported it. And now we're ready to compile our model and see the result of all our hard work. So first, before we get started, I want to note that I have Steam already running and the Source SDK. So if I open up the Source SDK, I want to show you what I'm compiling under. The engine version is the orange box. The current game is Half-Life 2 Episode 2. So this is what we're going to compile under. So you can set your settings to that. I'm going to minimize the window, and I'm going to go into the EP2 source folder, export it model, and in here we have Kevin.qc. If you remember, we went through the QC and all the files needed for compilation, and now that's going to come together. Now, when we compile, there's a couple different ways to do this. Some people use third-party programs. Some people, I'm sure, just drag and drop the QC onto the studio model executable. In this case, we have a shortcut. And some people are going to do what I'm going to show you. The reason why it's not a good idea to drag your QC onto your studio model executable is because if you have a mistake, the window just shuts down and you can't see, you can't see the error. You can't see the error message that it's throwing up. And I'm going to give you a demonstration. If I go into my QC and I put a period in it, and then I save, obviously this isn't going to compile correctly. So now I'm going to drag Kevin.qc onto the studio model shortcut. And so we have no idea what happened. And when you're compiling your model a lot, which you will do in the beginning stages, it's impossible to troubleshoot. So now I'm going to show you a different method for doing this, one that I think works better, and you don't need a third-party program. So if you go into your Start menu, and then Run, you want to find Run, and you type in CMD. This is a command prompt, and then hit OK. DOS window is going to come up. So we're back in the ancient days of computing here, but it's very useful. You want to drag and drop the studio model shortcut onto your DOS window. Then you want to press the space bar, you want to space, you want to go back into your exported model folder and drag and drop Kevin.qc onto your DOS window. Now you just hit enter and you'll see that it started to compile. Don't worry about the warning application framework up here at the top. It doesn't affect the compilation at all, so it's just something I haven't bothered to fix, so don't worry about that. But at the bottom you'll see error, and it says bad command, period, because it knows that's not supposed to be there. So basically you get an idea of what's happened and you can troubleshoot it, and this is much more useful than your Windows shutting down, obviously. So if we go back into our exported model folder, Kevin.qc, and get rid of the period, we're going to compile it properly now. So I'm going to save that. And this is what I like about using the DOS window. I can simply go back into my DOS window, hit the up arrow, and all the path names come up again, and then enter, and now it's compiling. And I think this is a lot easier than having to drag and drop on the Studio Model compiler each time. So it's completed it. We've got Kevin.qc, and our model's compiled correctly. If it hadn't, it would have thrown up an error at some point. So that's great that it's compiled. We're done with this window, so we can shut it down. And now we're going to look at the model. Well, let's first look at where it's put the compiled model, just for reference. So if we go up a directory, back in our exported model folder, go up a directory, up another directory, and up a final directory. Half-Life 2 Episode 2, EP2, and then Models. In your Models folder, there's Kevin. And that's our compiled models, so that's great. It's worked. So now what we're going to do is we're going to look at all our hard work in FacePoser. Okay, so let's go into FacePoser. So into your Source SDK window, double-click on FacePoser, and it's going to load up. I've got two models already loaded in here, but just ignore them for now. They're for demonstration purposes in a second. We're only interested in Kevin. So File up at the top, Load Model, and scroll down until you find the Ks. And here we have Kevin.mdl. So double click, and Kevin will load up and grace us with his presence. And there is Kevin. Now, Kevin unfortunately has a problem. And I know you were thinking, this is, we finished all the problems, but there always seems to be one last hurdle. If I double click on the tab that says Flex Sliders down here at the bottom, and I move his eyes right and left, you're going to see that Kevin has alien eyes. He has more than one pupil. And you might be wondering why. All I can say is that basically when the model decompiles, the pupil size is wrong in the QC and the texture is wrong. And the two together give you what is known as alien eyes. And it's rather weird. So we have to fix this. And it's the last thing, I promise you, it's the last thing we have to fix, which is great. So if I minimize FacePoser, we'll be going back to it in just a second. Let's minimize the Source SDK window. Okay, let's go into our EP2 source folder, exported model, Kevin.qc, and you want to scroll down to where the comment iData starts. Underneath that, you're going to see a line that starts with eyeball right eye. If you follow that line to the end, you'll see pupil _R and then a number which says 0.63. The pupil size is wrong, so we have to change it. We have to increase it. And we're going to increase it to 1.34. And underneath that, you'll see pupil _L. And we want to increase that to 1.34. The size is going to correspond to our texture alteration, which we're going to make in a minute. So you want to go ahead and save that. So File, Save. And this time I'm going to cheat a little bit. I'm going to drop the QC onto my Studio Model shortcut because I know that it works. It compiled correctly once already. So I'm just going to drag and drop that onto my shortcut, and it's going to compile. It'll take just a minute. When it's done, the window will shut automatically. So there we go. So we're done. So anytime you make an alteration to the QC, you have to recompile or the changes won't take effect. So now what we have to do, we have to go change the textures. So go up a directory into your material source folder, Kevin, and here you have pupil left, pupil _L, and pupil _R, which is basically our pupil texture. I'm going to use a paint program called Paint Shop Pro to alter mine. You can use Adobe or whatever. I'm just not very good with Adobe, so that's why I'm not using it. So we're going to load up Paint Shop Pro. There's my left pupil, but I need to alter the right pupil as well. And now what I'm going to do is, and this is very important, I'm not going to increase the overall texture. I am not going to change the size of the overall texture. I'm going to change the canvas size only because that would affect my pupil size. So make sure your background is black, and then I'm going to go canvas size 128 by 128. it was originally 64 by 64, which is wrong. So you want 128 by 128. Valve textures always work a multiple of 2, so that's why it's 128 by 128 instead of some other arbitrary number. So I've increased that one, and now I'm going to increase the other one. So I'm doing the canvas size, again 128 by 128, and that's done. So now I'm just going to save them, and I'm going to save right over top of the old ones. And there we go. So now I can shut down my program, and my pupils have changed. What I have to do, now that I've changed my texture, I have to recompile it. So I'm going to drag and drop pupil underscore R onto vtex, and that's done, and then pupil underscore L onto vtex. And so now I can just close down my window, and we've recompiled the textures and recompiled the QC. So now we're going to go back in the face poser and see what he looks like. Okay, so click on your choreography window, go back into face poser, and there's Kevin with his new eyes. The texture should have changed in the eyes. If you have any oddities, just click File, refresh at the top, because sometimes face poser has a problem updating itself. If you're still having a problem, close face poser down and open it up again. But as long as you follow the instructions, it should work fine. Over here on the flex slider panel, I'll demonstrate his eyes working. So they're working correctly now. No more weird alien eyes. And up and down. So his eyes are working pretty good. Show you some of the flexes. There he is blinking. And this is eyebrows. Now, I need to talk a little bit about the vertex animation for a minute. In episode 2, the vertex animation is a little bit different from episode 1 because they changed the mouth. If you compile this model, which some of you might, in episode 1, you're going to find that the vertex animation is much different looking than it is here. And that's simply because they have changed the mouth. So you need to keep that in mind. They're different engines, it's just a different procedure. If you're interested, I'll be doing a vertex animation tutorial after this one for Noesis, so you can keep checking the website for updates. The next thing I want to show you is the results of the include model command that we talked about early on in the QC, that we could gain assets from other Half-Life 2 models, which means we can gain a bigger animation library. So if I click on Animation tab down here at the bottom, the face poser window, and I type in, let's do salute. Okay, there we go. Let's scoop Kevin back. This is one of Barney's animations. The citizens do not have this animation. This is the animation from episode 1 where he's on the back of the train saying bye to Gordon, just in case you're trying to remember where you've seen it. So that's, you know, that's a new animation that Kevin's inherited from Barney. And I have Alex, episode 2 Alex uploaded here. This isn't decompiled Alex. This is the proper Alex. Let's just wait for it to switch over. And if I type in, let's get rid of this, flip, there we'll see Alex flip. I was going to do an animation from episode 1 called Sexy Idol, which is quite funny, but it's not included in episode 2, so I was quite disappointed with that, because if I go to Kleiner here, which is a decompiled Kleiner, by the way, I've given him Alex's animations, and we can see him doing some pretty cool moves. So he's inherited the assets from Alex. He's inherited her animations, and basically it's increased the animation library. But why you'd want to do this to Kleiner, I don't know. But basically that's, you know, let's click back on Kevin here. We have a finished product. Kevin is completely finished. He's fully functional. He has a new weight map. We've gone through so many steps to get him to this point, and it's great to see him. So I'm going to go ahead and close Face Poser because I'm finished. And what I'm going to do now is I'm going to show you a little video that I created in the episode 2 engine. It's not going to be, I'm not going to start up the episode 2 engine at the moment. I'm not going to start it up. I basically pre-recorded this for your entertainment, and it's just a little recap of everything we've learned, but it's also like a little movie. And it stars Kevin. He talks for us to demonstrate his flex animation. He walks and he deforms, and I'm also talking in it, doing some very hammy acting, but I hope you enjoy it.
Hi, my name is Kevin. I'm going to help recap the things you have learned. Dice.
Thanks, Kevin.
What did you do to me?
Here we have Fat Kevin. We took Mellow 2's head and welded it to Magnuson's body and added just a bit of weight.
More than a bit.
Let's briefly go over the things we have learned. First, we extracted our compiled model and textures using GCFscape. We did this so we could decompile with Cannon Fodder's model decompiler, which allowed us to get our model back into its original format and the textures into the compiled VTF format. We also briefly covered decompiling episode 2 models and the problems that might be encountered with them. Once we had our textures in VTF format, we used VTF Edit to revert them back to TGA files so we could import them into XSI, and also because this is the format that can be compiled using VTEX. Now that we had our model and textures in the correct format, we imported them into XSI via the Valve add-on. If you remember, it was a pretty straightforward process. Once in XSI, we fixed the border edges and got rid of leftover artifacts from decompilation and an extra weight map. We welded our edges back together using the Weld Edges operator, and we learned that each model is different, so welding the edges will be a little trial and error each time, but it will depend on the complexity of the model. After our model was whole again, we rigged it using the Valve Biped Guide and Rig. We then looked briefly at weight mapping and some of the problems associated with the default weight map. Finally, we imported a new weight map from the SDK example and used it for our citizen, finding it a better starting point than the default. Once we had our model rigged and weight mapped, we were able to finally export it, which was leading us one step closer to our final destination. Our level of detail models were also created and exported, and we learned why they were important to the final product. Now that we were finished with XSI, we could focus on the QC file that would control our eventual compilation. It required us to look at all the files needed for compilation and understand why they are useful. We could see how to add extra animations using the include model command and how each tutorial was like a puzzle piece we had been collecting throughout. Now they were finally coming together to create one complete picture. We compiled our textures using the EP2 VTEX tool, and then modified the path in the decompiled VMTs to make certain our textures would get applied to our model. After everything was in place, we compiled our model and viewed it in Phase Poser to see not only the vertex animation, but the result of the include model command in the QC. Finally, here we are in the episode 2 engine looking at our completed model. I created this little scene so you could see Kevin deform and what is possible once you go through this entire process. Now that you know how to decompile, you can alter just about any model contained in a Half-Life 2 world. Also, if you search the web, you will find lots of free models out there that XSI can import, like the .3ds. If you remember, I told you any model from another program will have double edges, but you can make these models game ready by welding, and there are some really nice models out there. You can also see that our Kevin is fully functional, and with the include model command you have more animations at your disposal, adding more depth to your modding experience. This is especially true of the citizens because they usually have the largest animation library, so adding their animations really opens up your choices and your choreography abilities. You could also decompile props and vehicles and maybe make new animations or add weapons to the entities. I also want to make you aware that I use knowledge I have gained from several of the Noesis videos to get Kevin working, so I suggest pursuing their selection. Finally, I want to say thank you for checking out the video. I had fun making it, and I hope you had fun learning from it. Now I'll let Kevin say a few words. Thanks, and bye.
For additional tutorials, make sure you visit noesisinteractive.com. Thanks, and happy modding!